Hi, my name is Tim Cicerci. I'm the Technical Services Manager here at Pepperl+Fuchs, and today I want to talk to you about IO-Link. I want to talk to you about how it fits into industrial automation and how is the technology used. So let's get started. Okay, here are some of the topics I want to discuss today. I not only want to talk about why and how IO-Link is used, but where does it fit in industrial networks and industrial automation. Once we do that, I just want to go through step by step kind of the installation and setup of IO-Link and talk about the three ways IO-Link is used, and that is control, configuration, and IO-Link expansion. Okay, before we jump into IO-Link, let's take a step back and talk about industrial networks first. I think there's three main industrial networks, physical layers left, and the three are Ethernet, which is a big bucket. I'll give you that. So Ethernet, we've got, Profinet, EtherCAT, Ethernet IP, those kinds of industrial networks. We got CAN-based networks that are CAN Open or J1939. And AS interface has been around for a very long time. I think it still has a place in industrial networks, industrial factory automation because of the long conveyor runs and such. So you can see here that the industrial network is often the communication between the PLC and the block, or the PLC and the device, assuming that it has quite a bit of bandwidth required. Okay, so we talked about our three types of industrial networks, Ethernet, CAN, and OSI, but what do I define as an industrial network? Really anything used for factory automation. Of course, it has to be used for the industry, number one. But number two, it's got to be addressable. So it's not just a one-to-one protocol. It's networkable, which means it has a Profinet name or a IP address, or in the case of EtherCAT, just the position on the wire defines its position on the network. Also, we got CAN Open or ASI or Profibus. You just kind of have an address number, so for example. So these are all types of ways that we communicate to an industrial network. And this is a little different than point-to-point protocols. So point-to-point protocol is not an industrial network because it just has basically bidirectional communication from one device to another. So I'll loosely define digital inputs and outputs as a bidirectional, let's say a 1-bit protocol. Analog, it's a little bit more than that, but it's still, you could pass a little bit more data. And I'll put into this bucket IO-Link, SSI, and RS-232 as well, because again, these are not networks, these are just protocols. And they are just one device to another. You can't address them, okay? And these signals are collected and transmitted back to your control system. They could be transmitted directly to a card in the PLC, but often they are consolidated into a block and then sent back on an industrial network. So here's a good representation of what I'm talking about, kind of putting it back together. We've got our industrial network from the block to the PLC, and then we've got our point-to-point communication going from the device back to the I/O block. So let's start talking about what this presentation is all about. It's about IO-Link. Why do we create it in the first place? Well, we have a lot of signals. We had that slide on the point-to-point communication protocols of inputs and outputs, serial, analog, and so forth. Well, that only gives you a little bit of information. And one of the reasons why we want to create IO-Link is that we want to have one signal replace it all. Okay, so IO-Link can take the place of all of these point-to-point protocols, giving you the ability to basically buy one block to replace them all. Okay, this is super useful. Okay, so now that we know that IO-Link can replace almost every point-to-point protocol, not all the time, but most of the time, what are some of the other reasons why IO-Link might be very useful, or why would it be used? Okay, so the one is it's open. That means anyone can make a device that's IO Link, either a master or device, and get it going. You can see, I mean, we've got hundreds and hundreds of manufacturers of IO Link devices. Okay, the worst thing would be point-to-point protocol that was ruled by one. That would never survive. The other thing is standard profiles. So we've only got a few profiles right now, but they're being built up. We've got user groups creating them. And what profiles really allow you to do is create a device that everyone understands. And it even gets to the point where I can create a device, and let's say another manufacturer can create a device. If they're made to the same profile, then we basically have our data and our parameters in basically the same layout. Okay, so the two devices are pretty interchangeable. There's always optional features that one manufacturer can put in that might help their customers specifically, but the general or the basic components are all going to be the same. So we've got the smart sensor profiles out right now. We might have drive technology, encoders, lighting. All of these are either done or in the works as far as IO Link profiles. And the other thing, let's talk about a little bit diagnostics. What IO Link allows you to do is not just send the digital like information, the analog like information back to your control system. It also allows you to send diagnostics. Okay, so the diagnostics could be going to your industrial network, but it could short circuit that and say go directly to the cloud. So now you have preventative maintenance, forward-looking type applications, trying to see how the system is running, how efficient is it, are any maintenance required, that kind of thing. So super useful that now we can get diagnostics down to the device and not just the block. So we know that IO Link can be used simultaneously a number of ways. Control for diagnostics and also configuration. Okay, so you can configure your sensor or encoder or light to perform a specific function and make the device do what you want. So here's an example of a sensor where, let's say out of the box, it might be in background suppression mode, but maybe you want to put it in a foreground suppression or hysteresis mode or something like that. So you can do this on the sensor quite easily, and it's a great way to use IO Link. Some people use, and we'll talk about this later, some people use the configuration of the sensor, and that's the only way they use it for IO Link, right? They don't use the process control data, they just use the configuration data. But the key is you can make the sensor do exactly what you want it to do. Okay, so IO Link, we already talked about this a little bit, where it can be used basically three ways simultaneously. But let's kind of dig into those three ways just a little bit. So it's used, number one, for control, right? If it's going to replace the digital in sensor or replace the analog valve controller, if it's going to replace the drive, it has to control, right, your machine, that bottom line. So the IO Link is fast enough to do this. We're talking about scan times in the 2, 3, 4, 5 millisecond range. It has the capability to control. Simultaneously with control, of course, cloud, right? We can take the data, basically send it to two places simultaneously, one for control, one for diagnostics. Secondly, we talked about this. Sometimes people use IO Link just for configuration. It's a great configuration tool. They might use a USB IO Link master or an IO Link master that connects to a web interface, and they just configure the sensor, and then they just use it like you normally would back in the day, right? They use a digital in or an analog signal directly, and they just use IO Link for configuration. And then sometimes IO Link is used, it's not like a network, but it's used for expansion, okay? So we've got IO Link, basically an IO Link device, which is a hub, which you can connect a bunch of sensors to. So you can imagine basically kind of a spider web of IO Link hubs out there consolidating data, and getting data back to the controller. However, you're not taking advantage of, diagnostics down to the device when you do this, but I've seen quite a few customers use this just for sheer expansion. Okay, now let's start into putting a system together step by step. Okay, so first thing I want to do is pick my sensor, pick my device. Number one, it's got to be IO Link because that's what we're talking about today. But we need to make a choice. Are we going to use what they call SIO mode, which means basically the IO Link sensor in digital mode, or are we going to use it full IO Link? Okay. If you look in the data sheet, it'll tell you how much data this one has available. So 3 bytes of input, 2 bits of output. This is a measurement sensor. So I'm really going to want to use IO-Link for this. Now, a lot of these sensors, in addition, also have an extra high-speed digital output, and this one is no different. So it's got IO-Link on the pin 4 and a high-speed digital input on pin 2. So you kind of get the best of both worlds with some of these sensors. So I think we're good to go here. All right, now we need to connect the sensor to something. So with these IO Link sensors, you can connect them, and they have basically a master port type. All right, so they can be a Class A or a Class B sensor, and you can connect it to a Class A or a Class B IO Link master. Okay, so in the data sheet, it'll actually tell you what type of compatibility you have. For example, compatible with master port type A. But let's take a look at these IO Link masters. You can get them with all Class A's, and that means they have IO Link on that standard pin 4 and an extra IO pin typically on pin 2, or you can get them kind of half and half. Now, any manufacturer can do it different, right? You can have 1A and 7Bs. You can have 7As and 1B, 6 and 2, whatever you like, okay? But you can see here there's a different mix. And the Class B basically has IO Link as a standard on pin 4 and then an auxiliary power connection. Well, how do I connect my sensor to these IO Link masters? Well, here's how you do it. You can connect, of course, a device that's A going to a master with an A port. You can go from A to B, but just be a little careful about the auxiliary power, right? If that B port's got auxiliary power running and you connect it wrong, you could fry your sensor. So I suggest 3-pin cables, which we'll talk about in a second. Or if your device has a B, you're going to connect it to a B port as well. Okay, so now that we've kind of chosen an IO Link master, either Class A or B port, let's pick the right cable. Okay, I've given some Pepperl+Fuchs model numbers here, but pick whatever cables you like. With the Class A's, for example, with this sensor, you're going to have 20 meters of max cable from the sensor to the IO Link master. And you're going to either choose a 3-pin cable if you only care about the IO Link, and that's probably what I might do. If you want the IO Link and the digital, you're going to pick 4-pin cables on a Class A port. If you're going to use a Class B port, because your IO Link device is Class B, you want to use 5-pin cables. So the 5 pins, you got your 3 for your IO Link, plus and minus, and then 2 for your auxiliary power connection. Okay, we haven't talked about the IO Link master much yet, but basically there's 2 selection criteria, I think. 2 main selection criteria. One, do you want to mount the device in the field with a high IP rating? Do you want to mount it in a junction box or a large panel? Also, what protocol do you want to support? Do you want to support, let's say, an Allen Bradley PLC with Ethernet IP, or do you want to go with Profinet for a Siemens PLC or something else? Okay, or do you want to go to the cloud? So, and again, it's not mutually exclusive. You can have multiple protocols on one device. So in my application, if I want field mountability, my Allen Bradley PLC, Ethernet IP, MQTT, this is the IO Link master I'm going to choose. It's going to be an ICE2 IO Link master. Model number isn't all that important depending on your supplier. I'm sure there's plenty of other model numbers available. An IO-Link master, once you've selected the device and the cable and the master, you need to take it the next step in configuring the IO-Link master port. You can actually configure it for, if you have a sensor, digital in or IO-Link mode, you can actually configure it for digital output mode as well. For example, if you want to use it to turn on a light or a solenoid or something like that. In our case, because we're using the sensor and we're using a measurement data, we want to configure it for IO-Link. But the default is usually digital in, sometimes it's IO-Link. Just make sure it's configured in the proper way. All right, your IO-Link device is connected to your IO-Link master. The IO-Link master has been configured for the correct, protocol like IO-Link. Now we want to do the programming. The beauty of IO-Link is that it's plug and play, which means once you plug it in, the data will just appear in the PLC and you're done. Okay, so you're good to go there. But what might you have to do is maybe you have to configure the sensor. Maybe you have to put an on or off delay in, or configure an LED pattern for a light or something like that. So get your configuration done for your IO-Link device. Maybe that's done on a web interface. Maybe that's done in the PLC. Maybe that's done secondarily with a USB IO-Link master. Just get your device configured the way you want it. And then let's store the parameters in the IO-Link master. And we're going to enable data storage. So that means if my IO-Link device fails, I can just throw it away. I can put the new one in, and automatically all those configuration parameters that I spent time to set up on the sensor will automatically be loaded from the IO-Link master to the sensor, and you'll be running. Very, very cool. So now we're in the PLC. Your sensor is configured. Let's talk a little bit about what kind of data that you get in your PLC or in the cloud, okay? And how fast do you get it? So the first is that process data. So process data allows you to control your system. This is cyclic, which means it's updated at a regular pattern. That pattern is basically that minimum cycle time, or the cycle time that's defined by the communication between the IO-Link master and your IO-Link device. The data sheet actually shows you what the fastest cycle time is. The actual cycle time is defined by the master, but either way, super fast. The second type of data that you're going to get in your PLC or in the cloud even are the events, okay? These are, number one, automatic. You don't have to configure them. You may have to configure the sensor to generate the events properly, but the event will get generated and be sent to you to use as you see fit. And maybe it's errors or warnings, something like that. Something that is basically sent on demand and sent only when there's a problem. And the third set of data is, I want to say, parameters. This could be identity information. This could be configuration information. This is going to be done on demand, and you can do it live. You can do it simultaneously with the process data. The beauty of these three types of data is that they all come in, and they can all come in simultaneously. It's not like you have to trade off one for another. It's automatic. You can configure simultaneously with events or process data. So get all this information all at one time. Just another quick slide about the process data. It's probably the most important data available because it's used for control. And if you look in the data sheets of all your sensing devices, you'll typically see a profile number, for example, type 3.3 or 2.4, as far as smart sensor profiles go. Just defines how much input data, how much output data. Maximum is 32 bytes for IO-Link, but there's a standardization that goes on for these types of devices. So if you know what the profile is, you know how the device or the data is laid out. All right, so if you want to get a clue as to how the data is laid out, maybe you're not that familiar with the smart sensor profiles and how it's all works, what you can do is open up one of the IODD files. The IODD file is going to define how the process data is laid out. You're not going to need it in the PLC or anything like that, but what you might want to do is kind of just check out the configuration parameters, the identity information, what types of features does it support, what events and warnings are available, maybe how to configure those events and warnings. So there's a lot of information in there. Every IO-Link device will have an IODD file that you can use or not, depending on the application. And IODD files are not required for control. If you can't find the IODD file, because it's from a manufacturer or their website's hard to navigate, either way, you can just go to the internet, go to the IO-Link page, and use the IODD Finder. This is a general site for all IO-Link IODD files across all manufacturers. It has a very cool built-in viewer, so you can take a look at all the information that we just talked about. I strongly suggest that you bookmark this page and go to it when you need IODD files. Okay, so we talked about using IO-Link for control, but I also mentioned that you can use IO-Link for configuration only. In that case, there are IO-Link masters that you can use directly with your PC, just the USB port. You plug it in, plug your sensor in, you're ready to go. The configuration software often used is called Pactware. If you're going to use an Ethernet or you want an Ethernet connection, I suggest an IO-Link master that you can upload the IODD files to. You can configure those devices that way as well. The third way IO-Link is often used is with the hubs for basic expansion. Unfortunately, your sensors are still either digital or analog or something like that, but what it allows you to do is take a lot of sensors or a lot of outputs into one kind of consolidation IO-Link master device. So the IO-Link basically ends at the hub and doesn't extend to the sensor. But, if that's what they want, that's what you want, So we've got hubs that are just for digital, for example, for inputs or combinations of ins and outs. We've also got converters. So maybe the hub is just one device that converts IO-Link to analog. That's okay. There's also some newer devices out there. The hubs don't have to be field mountable. They can also be panel mount, right? So you could have a push button station for or LED, something like that. So IO-Link, I've seen this quite a bit, used for just IO expansion, not for configuration or control. All right, let's bring it back together. So in conclusion, IO-Link is plug and play. As long as your IO-Link master is configured for IO-Link, just plug your up to 20 meter cable from your IO-Link device to the IO-Link master, and it'll run. So that's quite nice. Pick the master based on the features that you need, the protocols, the IP rating, and the mounting. Choose the IO-Link master port that you need, whether that be A or B, and pick the right cable so you don't do any damage to your IO-Link device. Go ahead and configure the sensor the way you want it to, or configure your valve, whatever IO-Link device you have. And when you're done, when you're happy with it, enable data storage. That way, the maintenance guy down the road, all he has to do is unplug it, throw it away, put the new one in, auto-configured, you're done. Thanks for watching. And again, my name is Tim Cicerci. Hope you have a great day. Please don't forget to go to our YouTube channel. And any questions, give me a call. Thanks. Bye.